so now let's talk about something else, which is data augmentation. So say you have a data set. What can be really useful sometimes is to artificially augment your data set through data augmentation. So this is one thing that actually AlexNet leveraged in their original publication. So AlexNet used both cropping and mirroring, and we're going to look at both. So the idea behind data augmentation is you want to do some kind of transformation to your image such that it preserves the labels of your image. So for example here, we randomly pick a 224 by 224 patch from our 256 by 256 image. And we use that crop as the input to our network. So you can see here we have our dog, and it's a 256 by 256. If I crop it, right, well, seeing as the dog takes up most of the image, the label dog is still associated. And by cropping at different spots, we now have different representations of this dog that the network can then train on. So this is one way to artificially augment our data set. And again, AlexNet had used this in their original implementation. And this is why they used an input of 224 by 224, so that they could use this cropping and artificially augment their data set. And they found that this was a trick that particularly helped for training their network. Another thing that we can do is mirroring. So not only can we crop, but then we can flip a coin and decide if we want to mirror our data. So in the case of a dog, if you mirror the image of a dog, it should stay a dog. Right? Now, you should be careful with these kinds of tricks and make sure that it applies to your data. For example, if you mirror text, it doesn't necessarily stay the same text. If you mirror a digit, say on MNIST, then you're completely transforming the representation, unless you have maybe symmetric digits. So in the case of ImageNet, it turns out that mirroring your images is a valid transformation for most objects, right? As humans, if you look at something in the mirror, it should be the same as if you look at something without looking at it in the mirror. There's another kind of augmentation you can do, which is rotation. So in this case, we take our image, we slightly rotate it. And again, if it's an object in the real world, if the camera angle changes slightly, that object or the representation of that object shouldn't change. Now, of course, this is domain dependent. If you do a rotation on a spectrogram, I can't imagine that that could be very useful for your network to learn. So when you're applying data augmentation, it can be very useful, but you also have to be sure that you're applying it in a way that makes sense and doesn't impact the labels when you're doing your data augmentation.